Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we continue the mathematics paper 2nd from 12th science, and chapter is binomial distribution. We continue the problems in chapter binomial distribution. Now the next problem is, there are 5 defective atoms in a large bulk of atoms. What is the probability that a sample of 10 atoms will not include more than one defective atom? Now, see here, we have given there are 5 defective atoms. There are 5 defective atoms. Now, if we define, let P is the success, and success is the selection of defective atom. So let X equals to defective atom. X equals to defective atom. Now, since X is a selection of defective atom and it is considered to be a probability of success, so we get probability of success P, which is given to be 5%. Now we know that 5% means 5 out of 100. 5% means 5 out of 100. So it becomes 1 upon 20. So we get the probability of success equals to 1 upon 20. Now we also know that since P plus Q, where Q is the probability of failure, P plus Q is 1, which implies that, or which gives Q equals to 1 minus P, that is equals to 1 minus 120. So it gives 19. If you take the cross multiplication, it gives 19 upon 20. So the probability of failure Q is given 19 upon 20. Now the probability of success P is 1 upon 20. Probability of failure Q is 19 upon 20. Now second is given that a sample of 10 defective atoms. Sample of 10 atoms are selected. So we can also write here n equals to 10, since a sample of 10 atoms is considered. Now we have the formula. We have, what is the binomial distribution? That is probability of random variable x equals to small x, that is the random variable x taking the value x, equals to NCX P raised to x into Q raised to n minus x. Now here we have to find that probability of not including more than one. Not including more than one. So here we have to find not more than one means probability of x is less than or equals to 1. Not more than 1 means less than or equals to 1. So here now from above equation, or say give it as an equation number 1, therefore by equation 1 we can write probability of x is less than or equals to 1. Now for x is less than or equals to 1, the possible values are 0 and 1. So this can be written as probability of x equals to 0 plus probability of x equals to 1. Now putting the values of x equals to 0 and x equals to 1 in this equation 1, also the values of n and p and q, we get the required probability, that is probability of x is less than or equals to 1 is 10C0. 10C0. P means 1 upon 20. 1 upon 20 raised to 0 into 19 upon 20 raised to 10 minus 0. This is the value of the term when we put x equals to 0 in equation 1, that is probability of x equals to 0. Now plus, now put the value of x equals to 1. So we get 10C1 1 upon 20 raised to 1 and q, that is 19 upon 20 raised to 10 minus 1, putting all these values. Now simplify this one. Now we know that 10C0 means 1, so it becomes 1 into something raised to 0, that is 1 upon 20 raised to 0 is always 1, so again 1, and this term as it is, that is 19 upon 20 raised to 10. Now plus, we know that NC1 is always 1, so by using that result, 10C1 is 10 into 1 upon 20 raised to 1, and here it is 19 upon 20 raised to 9. 19 upon 20 raised to 9. Now simplify this one. So again it becomes probability of x is less than or equals to 1, which is equals to 19 upon 20. This term 19 upon 20 raised to 10 as it is, plus, now here this is 10 into 1 upon 20, that is we write here it is 10 upon 20. 10 upon 20 into 19 upon 20 raised to 9. 19 upon 20 raised to 9. Now we simplify it. We use the law of indices. So taking 19 upon 20 raised to 9 as a common factor. 19 upon 20 raised to 9 as a common factor. Now use the law of indices. Here it is 19 upon 20 raised to 10. So remaining term is 19 upon 20. Since this 19 upon 20 into 19 upon 20 raised to 9 becomes 19 upon 20 raised to 10. Now this term, so remaining term is only 10 upon 20. So it is 10 upon 20 into 19 upon 20 raised to 9. Now this addition becomes 29 upon 20 into 19 upon 20 raised to 9. This is the required probability that not more than one defective atom is selected. Not more than one means less than or equals to one defective atoms. Now we see the next example. Now see here, we draw the 5 cards. Successively with replacement. Means we select one card, replace it into a deck, then we select the next card. From a deck of 52 cards, when we say that it is the deck of 52 playing cards, remember that it is always, we consider it is a well-shuffled deck. It is a well-shuffled deck. Now we have to find the probability that. Now observe, in all these cases, we ask the probability for the suit spade. So here we have to consider probability of success with respect to this spade. So we define here, let X is a spade card is selected. A spade card is selected. We consider X, that is the success, as a spade card is selected. So the probability of success, that is probability of getting spade card. Now we know that in well-shuffled deck of 52 cards, there are 13 spade cards. So probability of success is 13 upon 52. 13 upon 52. Now after simplification, it becomes 1 upon 4. 1 upon 4. This is the probability of success. That is, probability of selected card is a spade card. Now again we know that since P plus Q equals to 1, which implies that Q equals to 1 minus P, which is equals to 1 minus 1 by 4, which is the 3 by 4. So we get Q equals to 3 by 4. We get both the values, that is probability of, this is the probability of failure and this is the probability of success. Now also the 5 cards are drawn. That is, we make the selection 5 times. So it means that it repeats 5 times. So we write here also n equals to 5. Also n equals to 5. Now we have for the formula for getting x success in binomial distribution, that is probability of x equals to x is equals to NCX P raised to x into Q raised to n minus x. Now let's give it is an equation number 1. This equation number 1. Now we solve these 3 sub questions. Now let's consider A. Consider A option. Now in A, all the 5 cards are spade cards. So we have to consider x, the small capital value of x equals to 5, because we need all. All means 5 cards are spade. So we take x equals to 5. Now the remaining terms, that is P equals to 1 by 4, Q is 3 by 4 and n is 5. These are all the parameters. Now putting all these values in equation 1, and therefore by equation 1, probability of x equals to 5, that is getting all 5 spade cards, equals to 5C5 1 by 4 raised to 5 into 3 by 4 raised to 5 minus 5. 3 by 4 raised to 5 minus 5. Now take the calculations. Now 5C5 means 1. So it becomes 1 into 1 upon 4 raised to 5 into 3 upon 4 raised to 0. 3 upon 4 raised to 0. Now if we now 3 upon 4 raised to 0 means again 1, this 1. So remaining term is 1 upon 4 raised to 5 only. And if we know that 4 raised to 5, if we take the calculation, it becomes 1024. It becomes 1024. So probability of x equals to 5 is 1 upon 1024. 1024. This is the probability that all the 5 cards are spade cards. Now next one. Next is only 3 cards are spade cards. Now we have to find the probability of 3 cards are spade card. That is, we have to find when x equals to 3, we have to select 3 spade cards. Now the remaining terms as it is, that is P equals to 1 by 4, Q equals to 3 by 4 and n equals to 5. Now again putting all these values in equation 1, therefore we write here, therefore by equation 1, probability of x equals to 3 is 5C3 1 upon 4 raised to 3 into 3 upon 4 raised to 5 minus 3. Now make these calculations. So this 5C3, now this 5C3 is equals to 5 into 4 into 3 divided by 3 into 2 into 1. Now 1 upon 4 raised to 3 as it is. 1 upon 4 raised to 3 as it is. Now this 5 minus 3 becomes 2. 5 minus 3 becomes 2. So it becomes 3 upon 4 raised to 2. 3 upon 4 raised to 2. Now make this calculation and simplify them. Now this 3 gets cancelled. 2 2s are 4. So it becomes 5 into 2, that is 10. 5 into 2 becomes 10. Now here it becomes 1 upon 4 cube using law of indices. Here it is 3 square upon 4 square. So totally it becomes 10 into this 9 upon 4 raised to 5. 4 raised to 5. So it becomes 90 upon 90 upon 1024. 1024, because we know that 4 raised to 5 is 1024. Now if we divide it by 2, it becomes 45 upon 512. 512. This is the probability that x equals to 3, that is selection of 3 spade cards. That is selection of 3 spade cards. Now the third sub question. Now in third sub question, none of the spade card is selected. So here we see the number 3 or C. Now in C we have to find the probability that none of is the spade card, that is x equals to 0. So x equals to 0. Again P equals to 1 by 4, Q equals to 3 by 4, and N equals to 5. Now putting the equations in equation 1, therefore by equation 1 we can write probability of x equals to 0 equals to 5C0 1 by 4 raised to 0 into 3 by 4 raised to 5 minus 0. So it becomes 5C0 means 1 into 1 into 3 by 4 raised to 5. So it becomes 3 by 4 raised to 5. This is the probability that none of the spade card is selected. None of the spade card is selected. Now if you simplify this one, this becomes 3 raised to 5, that is 243 divided by 1024. This is an final solution. So we find all the 3 cases. Now first one is all 5 cards are selected. So we take here x equals to 5. Now in second, 3 spade cards are selected. So here we take the x equals to 3. And lastly, in third, none is spade card is selected. So here we take x equals to 0. Now we consider the next example. So for next example, now see this. Here in multiple choice of questions, for each question there are 3 possible answers. For each question there are 3 possible answers from which each of the 5 questions, means for each question we have given 3 alternatives, and out of that 3 alternatives, one is the correct alternative. So here total alternatives are 3, out of which one is the correct alternative. So the probability of getting correct solution or selecting of correct alternative, that is the probability of success, becomes 1 by 3. Probability of success becomes 1 by 3. Now again, since P plus Q is 1, that means, or which implies that q equals to 1 minus p. That is, we get q equals to 1 minus 1 by 3, that is equals to 2 by 3. And such a 5 questions are given. Such a 5 questions are given. So we can write n equals to 5. We can write n equals to 5 here. Now we have to find the probability that a student gets 4 or more correct answers. Student gets 4 or more correct answers. That is, we have to find probability of x is greater than or equals to 4. We have to find probability of x is greater than or equals to 4. Now we have the formula, that is probability of getting x success is NCX p raised to x into q raised to n minus x. Now, by using this formula, or say equation number 1, we have to find probability of x is greater than or equals to 4. Now, probability of x is greater than or equals to 4. Since only 5 questions are given, so for probability of x is greater than or equals to 4, there are only 2 alternatives, that is taking the value of x equals to 4 and x equals to 5. So this can be written as probability of x equals to 4 plus probability of x equals to 5. Now putting these values, putting all the values in equation 1, we get the solution, or therefore here we write by 1. By equation 1. Now putting all these values in equation 1, or we can say by equation 1, we can write here now 5c4 into 1 by 3 raised to 4 into 2 by 3 raised to 5 minus 4. This is the value for x equals to 4. Now plus 5c5 1 by 3 raised to 5 into 2 by 3 raised to 5 minus 5. Now, if we make this calculation, 5c4, that is n minus 1 is n, so it becomes 5 into 1 by 3 raised to 4 into 2 by 3 raised to 1 plus 5c5 means 1 into 1 by 3 raised to 5 into 2 by 3 raised to 0. Now if we take these calculations, this becomes 5 into this 2, and this 3 raised to 4 into 3 raised to 1 becomes 3 raised to 5. 3 raised to 5, and plus here it becomes only 1 upon 3 raised to 5. Now we know that the 3 raised to 5 is 216. So it becomes 10 upon 216 plus 1 upon 216, and so the final solution, that is probability of x is greater than or equals to 4, that is a student give the correct 4 or more than 4 questions. So it becomes 11 upon 216. So we get the solution. Now here we stop. In next lecture we see some another examples on this binomial distribution. Thank you.